Good morning, friends. Yesterday we discussed related to quantization and sampling. That was the simple part or overview of the quantization. Today we are going to start what is exactly the quantization means. See here, some different parts are going to be conducted. Often the domain and the range of the original signal x of t are molded as continuous, and that is the time or spatial coordinate t is allowed to take an arbitrary real value, perhaps over some intervals, and the value x of t of the signal itself is allowed to take an arbitrarily real value. Again, perhaps within some interval. As mentioned previously, such signals are called as analog signals. We categorize these two signals, that is analog and digital signals. A continuous model is convenient or some situation, but in other situations, it is more convenient to work with digital signals. That is, signals which have a discrete or domain and ranges. The process of digitizing the domain is called as sampling, and the process of digitizing the range is called as quantization. Most devices are encountered deal with both the analog and digital signals, and digital signals are particularly robust to noise and extremely efficient and versatile means for processing the digital signals have been developed. On the other hand, if we discuss in certain situations along signals are sometimes more appropriate or even necessary. Let us take one example. Most underlying physical processes are analog, or at least most convenient models as analog, and including the human sensoriometer system, and hence the analog signals are typically necessary to interface with the sensor as actuator. Also, some types of the data processing and transmission are most conveniently performed with analog signals. Thus, the conversion of the analog signals to digital signals and vice versa is an important part of many information processing systems. In this chapter, we consider some of the fundamental issues and techniques in converting between analog and digital signals. And for sampling, three fundamental issues are to be considered, that is, how the discrete time samples obtained from the continuous time signal. Second, how can we reconstruct a continuous time signal from a distinct set of samples? And thirdly, under what conditions can we recover the continuous time signal exactly? And for quantization, how many quantization levels should we choose? Okay, so this digitization of the analog signal basically involves the rounding of the value which are approximately equal to the analog values. The method of sampling chooses a few points on the analog signal, and then these points are joined to round off the values to the near stabilized value. Such a process is called as quantization. I'm repeating, this digitization of the analog signal means analog to digital conversion basically involves the roundings of the value which are approximately equal to the analog value, and the method of sampling chooses a few points on the analog signal, and then these points are joined to round off the value, means round figure we have to consider to a near stabilized value. Such a complete process from analog to digital conversion is basically known as quantization. See here, this quantization and analog signal means the analog to digital converter basically performs the different types of functions to create a series of digital values. whatever it may be, a series function or parallel function out of the given analog signals. And the following figure, this basically represents an analog signal, and these signals to get converted into digital and has to undergo the sampling and quantization. The quantizing of an analog signal is basically done by discretizing the signal with the number of quantization levels, and this quantization is representing the sampled value of the amplitude by the finite set of the levels, which means converting a continuous amplitude sample into a discrete time signal. See this diagram. Here the continuous values are given. Initially it rises to upward level, then it will start to a downward level. But these signals are continuous from analog to digital converter. The same signal will be applied here, and it shows how the analog are quantized. The blue line represents the analog signal, while the brown lines are represented by the quantized signal. Both the sampling and quantization result shows the loss of the information, and the quality of the quantizer output depends upon the number of the quantization level used. The discrete amplitude of the quantized outputs are basically called as representation of the level or reconstruction of the level. Again, repeating this point, the sampling and quantization result will show the loss of the information, and the quantity of the quantization output completely depends on the number of the quantization levels used in this process. This discrete amplitude of the quantized output are called as representation level or reconstruction level, and the spacing between the two adjacent representation level is called as quantum or step size. This following figure basically shows the resultant of the quantized signal, which is the digital form of the given analog signal, and it is called as stair waveform in accordance with the shape. Thank you.